Hello students, I am Dr. Sanjay Ponia. When we were doing first unit of computer graphics, then I left a topic that was clipping. And I told you that we will complete this topic after unit 4 as our fourth unit has been complete and we discuss clipping over there also. Now the concept of clipping will be clear to you. And if you have remembered, then we discuss the same arrow, that is Cohen Sutherland arrow over there. So this is the arrow, that is Cohen Sutherland line clipping arrow, has been given two times, once in first unit and second in fourth unit. So, and this is very important topic. So I will try to understand you once more about this. So let's start Cohen Sutherland line clipping algo. In Cohen Sutherland line clipping algo, our first purpose is to give the region codes as this is a window, this is a window, and there are XL, XR, YB, YR. That is, XL is low level coordinate on X axis. This is right coordinate on X axis. This is below coordinate on Y axis, and this is the top coordinate of Y axis. So in these, the size of the window will be given to us in the form of XL, YL, XL, XR, YB, and YR. And we have to find out that the code of the other regions, that is this region, this region, this region, these all different regions are what? So we can assign the codes using 4 bit, that is bit 1, bit 2, bit 3, bit 4, and bit 5. In these bits, we can store, or 1 bit is used for that the region is in the top, the region is in the bottom, the region is in the left of the window, or the region is in the right of the window. But it's not necessary that we have to take this sequence as top, below, left, and right. We can change the sequence also, but we have to keep one thing in mind, that whatever the sequence we are following in one region, that should be followed in another region also. So the rules to decide or to find the coding of different regions are: first we have to check the x coordinate. We have to check the value of x coordinate. If the value of x coordinate of a point is, suppose I am considering this point, if the value of this point is less than this, less than the left value, then set bit 1 to 1. So this is for the left. As I told you that we can change the sequence. So this is for the left. This is for the left. So when the value of x is less than XL, then in that case we have to set the bit 1 else 0, as this is in the left, so we can. And the second one is when the value of x is greater than value of x is greater than xr, then this is in the right hand side, means value of bit 2 is 0, so this is for right hand side. We will compare the y coordinate. If the y coordinates is below y axis, this is the value of yb. If the coordinate is over here, then the value of bit 3 will be 0. So this is for below, and last one, that is bit 4, is for the above. So we have to write the codes of each and every region in this sequence, that is A above, B below, R right, and L left. So this is the way, this is the different rules through which we can find out the region codes of different points or different coordinates. To find out the coding of different region, there should be the thing that the left hand side value of x coordinate and right hand side value of the x coordinate, whereas below value of y coordinate and top value of y coordinate should be known to us. Then we can find out the region code for any region. So this was the basic concept to find out the region code of any region with respect to window. Whatever the region code we are writing over here, these are with respect to the window 000, as the region code of this is 000, because the, suppose I am considering a point over here, then this point is in the right of xl, means xl means left bit will be 0, right will be 0, because it is not in the right of the xr. The yb bit is also 0, that is below bit will also be 0, because this is not below than yb, and above bit also will be 0, as it is not above the yt. So this is the basic concept to find out the region code. After assigning the region code, we have to check that the line is visible, invisible, or partially visible. So in the question, two things will be given to us. The size of the window will be given to us, means the coordinate, this one x minimum, x maximum, y minimum, and y maximum will be given to us. So based on these coordinates, based on these value of the window, we are able to find out the region of any line, and after finding the region of any line, we can find out the region code. So in this, we have to be given two endpoints of a line, and have to be find that the line is completely invisible, completely visible, or partially visible. And the output is that we have to click the line that is outside the window. This is our motto over here. So first step is assign a region code for two endpoints of a given line. Suppose this is our window and a line is given to us. Any line is given to us. Suppose this is the line. So first we have to assign the region code for both the points, that is suppose point A and point B. So first step is this one. Step 2, if both endpoints have a region code 000, then line is completely visible. Means if both the endpoints, means one endpoint this is and second endpoint is this of the line, it means that these line is completely visible. This is in step 2. Step 3 is, if this is not the case, means if the line is not completely inside or visible, then we have to perform the logical AND operation of both the region codes. Suppose the region code of this is, as we know, this is 0000, and we will perform the AND operation of the region code of this code. This, suppose this is 0010, and if the result is not 0, means if this is a non-zero value, then the line is completely outside. Means suppose this is a one point and this is another point, and we are going to find out the region code for this and region code for this, and we are performing a AND operation between these two, and that value is non-zero, it means this is completely outside. So there is no need to clip. But there is third case also, the line is partially inside. If these two cases are not, then third case will exist, and that is partially inside. Sorry. In this, we have to find out the endpoints of the line that is outside the given rectangle. Means first of all, we have to find that which point of the line is outside from the window. This point, or suppose this is a line, then we have to find out that which one point of the line, this point or this point, this point or this point, is outside from the window, and it can be found based on the region code. So choose an endpoint of the line that is outside the given rectangle. Find the intersection point of the rectangle boundary based on region code. So we can find out that where it is going to touch to boundary of the window. Then replace endpoints with the intersection points and update the region code. And we have to repeat step 2 until we find a clipped line, either trivially accepted or trivially rejected. So this is the basic concept for the Cohen Sutherland line clipping algo. For partially in and partially out, you can see once more that if the line is this one, okay, I will tell you in the next slide. Let me clear it and come on the next slide. So I told you all these cases differently. So this is when the line is completely visible, as in the case you can see in the last slide that when the region code of both the endpoints are 000, then the line is completely outside. You can see from here that region code of these point C and point D of line CD are 000 and 000, means both the endpoints of the line, that is C and D, the region codes are 00, so it means this is completely visible. And I told, in case of completely invisible, we have to perform the region code of 1 point to the region code of 1 point a AND operation. When we will perform a AND operation between the region code of 1 point with the region code of another point, and the value is non-zero over here. You can see here that the region code of C is 0001, and region code of D is 0101. And when we are going to perform the AND operation between these two, so and between 1 and 1 is giving us 1. So this is not non-zero. So this is the reason we discard this line completely. These are two cases where the line is either completely visible or incompletely visible. There is third option, that is when the line is partially visible. Over here, there can be two cases. One endpoint is within the visible window and another point is outside the window. One endpoint is inside the window. You can see from here, this is the window and this is a line. So one endpoint of the line is inside the window, this point is inside the window, and this point is outside the window. So first is one endpoint is within the visible window and another is outside. And second case is that both the endpoints are outside the visible window, means one point is over here and second point is over here. But you can say that when I join these 2 points of a line, then line is partially visible and partially invisible. So you can see from here that this is also a visible line. So there are two these different cases. We can solve these two in the different ways. So now I will explain you that how we can find out these two different cases separately. So let's discuss about the first case, where the first point of a line or one point of a line is inside the window and second one is outside the window. You can see from here that the region coordinate of C is 000 and the region coordinate of D is 0010. And when we are performing a AND operation between these two, then we are not getting a zero. Sorry, we are getting a zero, means we are not getting a non-zero value. So first we have to find out that the second point of the line is in the right, in the left, in the top, or in the bottom. So this can be easily find out by the region coordinate of the point. So from here, you can see that the second bit is 1 and this second bit represents right. In our region code, the second bit from the right represent the right and this represent the left. This is the region code we assign in the starting. So now if we do the logical AND operation between these two regions and we will get a 0 as I told you. So the line is partially visible. A C edge over here, C is inside the window and second point that is D is 1. So we have to find out the intersection with right edge. That is, we have to find out this intersection. And when we will find this point, we can say that this line is visible or this line is invisible, or we have to clip this line. So it can be find out by using the general equation of a line, that is y equals to mx plus c. As I know both the coordinates in starting, that is the value of c and d, then by using the values of c and d, I can find out the value of m, that is m equals to y2 minus y1 upon x2 minus x1. And in the second case, when I got the value of m, I got 1 point, I got the value of m, I know the value of x coordinate. I know the value of x coordinate of the intersection point. So I can find out easily the value of y coordinate of intersecting point. So this is the way in which we can perform the calculation, or we can find out the intersecting point of a line. This is the second case of partially visible, in which you can see over here that these are two different endpoints, that is C and D, where the region code of point C is 0001 and region code of point D is 1000. And when we perform the AND operation of these, then we get a non-zero value. We did not get a non-zero value, means we get 0000. So it means this is partially visible. In that case, it is visible to us that this line intersect at 2 points. One is at F and second point is at E. Second point is at E. So we have to find out the coordinates of point E and F. And we can find out it easily as we discussed in case 1. The same operation or same process we have to perform two times, once for this intersection point and second for this intersection point. But the value of the m, that is slope, will be same over here. After finding the slope, of the line, I know the coordinate of D, and when I want to find out the intersection point of F, then in that case, I know the value of Y. The intersecting point with Y, that is Y2, t. This is yt. So I can find out the value of x coordinate, and over here I know the value of x coordinate, so I can find the value of y coordinate easily. So over here means when this is partially visible, so in case 2 we have to perform the operation of partially visible, that is case 1, 2 times. So this was about the Cohen Sutherland line clipping algorithm. We discussed this in the fourth unit also, and now as per the syllabus we discussed in first unit also. So in the next we will discuss the midpoint line clipping algorithm of the first unit. Thank you. Thanks a lot.